I think we'll go ahead and get started. Welcome to the monthly Conexxus webinar series. Today we're going to talk about how we can leverage data science to improve retail data security. And our presenters today are Ashwin Swamy from Omega and Thomas Duncan, also from Omega. Our agenda today, I'll go over a few housekeeping items. Presenters about Conexxus, we'll go through the presentation, and then we'll have questions and answers session at the end. It will be made available in approximately 30 days. You can go to YouTube to find it, or you can go to the conexxus.org website to find it. You will receive a link to the slide deck. If you finish the webinar and complete, there's a few short survey questions. And if you complete the survey at the end of the webinar, you will receive a link to the presentation slides approximately 30 to 60 minutes after you've completed the survey. All attendees are on mute, and so we ask that you ask no specific vendor questions and type your questions into the question panel in the GoToWebinar session on your screen. If you have any suggestions for future webinars, please go to info@conexxus.org. So today, our Conexxus host is Allie Russell with Conexxus. So Allie, thanks for hosting us today. My name is Cara Gunderson. I'm your moderator, and I am the chair of the Conexxus Data Security Standards Committee. My day job, I'm the point of sale manager at Citgo Petroleum. Today we have two really great speakers. These guys know their stuff, and that's Ashwin Swamy, who is a director at Omega, and Thomas Duncan, who's a security strategist also at Omega. Next slide, please. A little bit about Conexxus. They are an independent, nonprofit, member-driven technology organization. For instance, they have very few staff members and are basically run by volunteers such as myself, such as the gentleman here, Ashwin and Thomas from Omega. They're also volunteers and members of Conexxus. And so we've got a really great team and are always looking for more folks that want to learn more, that are interested in contributing to the greater good of Petro and setting standards for data exchange, security, mobile commerce, and to help provide a vision. You know, they're really identifying emergent technology and trends. And Conexxus is really an advocate for our industry. Here's our Conexxus webinar schedule. Today, we have the Leveraging Data Science to Improve Retail Data Security. In July, we have Security Innovation doing a roadmap to Vulnerability Disclosure Program. In August, we'll have Linda Toth from Conexxus and a few other dignified guests talking about moving towards outdoor EMB. In September, we have several subjects that George is trying to figure out which one is the best one for our September timeframe from Omega. And then in November, we have Joe back from Security Innovation to do building a scalable security engineering team. Of course, we are always interested in future webinar ideas, so that is actually one of the survey questions at the end. And we do invite everybody to attend the next show, which is October 7th through 10th in Las Vegas. The Tech Edge is in partnership with Conexxus, and some of you that have been around for a while might remember the old NACS Tech days, and NACS Tech has now morphed into the Tech Edge, which is during the next show. So it's great. And then, of course, Conexxus thanks their annual Diamond sponsors for their 2018 annual conference that are listed here. So with that, I'm going to turn this over to Ashwin and Thomas. Gentlemen, welcome, and thank you for sharing your time and knowledge today.
Thanks, Cara. Thanks, everyone, for joining today's presentation. So the question we're asking today is whether convenience retailers can leverage data science to improve data security in the store. So to answer this question, we're going to try to understand how data science can make security teams more intelligent and accurate in their ability to detect threats. As part of this discussion, we'll talk through data science concepts from a high level so that you understand how data science relates to other buzzwords out there like machine learning, AI, and analytics. We'll then cover how data science methods can ease the burden of managing security events. And we'll also look into how security can work alongside other analytics programs that your business may be introducing to improve marketing or operations. And finally, we'll do our best to ground this discussion in the realities of running and managing C-store operations, whether you're a large or small retailer. But first, let's understand the problem before we start thinking about the solution. I'm sure some of you heard about the attack that happened this week at Tesla Motors. What we have up on the screen here, which was originally reported by CNBC, is the email that Elon Musk sent just earlier this week to his employees. And I'm going to read straight off the email here. So he says, "I was dismayed to learn this weekend about a Tesla employee who had conducted quite extensive and damaging sabotage to our operations. This included making direct code changes to the Tesla manufacturing operating system under false usernames and exporting large amounts of highly sensitive Tesla data to unknown third parties." And he continues, "The full extent of his actions are not clear, but what he has admitted to so far is pretty bad. His stated motivation is that he wanted a promotion that he did not receive. In light of these actions, not promoting him was definitely the right move." So the email continues on into other potential motivations of the insider threat. And I think, Thomas, you were just reading an article earlier today. Maybe you want to jump in and give some what the current state is.
Sure. So the employee actually admitted that he had wrote code to export data, on a periodic basis for multiple machines. And he was able to kind of, hide what the actual identity of the user that was exporting this code. So it tried to cover up his own tracks and make it seem like someone else was doing it rather than him. All in all, he did get caught and has admitted to it, though.
Well, good thing he was found. The reason really that we brought up what happened at Tesla is that there are many directly analogous examples that take place in C-stores. So let's look at the key terms that are featured in this email here. Making direct code changes to the Tesla manufacturing operating system. That's something that file integrity monitoring, a PCI requirement, might be looking to detect. The second is having false usernames. So there's obviously some issues related to user access at play here. And the third piece is exporting large amounts of highly sensitive Tesla data. So obviously, the third step in this attack was transmitting the data either through email or through USB or other means. And so let's look at what would happen at a C-store that is very similar. The first is a bad actor, internal like what happened at Tesla, or external, attempts to log into a POS system, a site controller, a fuel controller, or an EPC, or not any other machine that they can get access to. Now, one thing we've seen at Omega is that social engineering attacks are very frequent at C-stores. Callers or visitors can frequently pose as vendors with minimum resistance. Sometimes they may find that machines are readily accessible because the door to a back office is wide open. We've seen that as well. And so continuing in this hypothetical example, if a bad actor succeeds in accessing a system, obviously he or she may try to access particular files, either to remove that sensitive data, excuse me, or simply to disrupt operations. As an example, Thomas, what would happen if someone jumped onto a site controller in a C-store? What kind of damage could they do?
They could potentially use that site controller to pivot from machine to machine, and then from there, jump around and maybe collect full PAN data, if they can get to, the payment process, the payment controller.
Absolutely. And so as we saw in the Tesla example, to look at the fourth point here, in the case of stealing sensitive data, the bad actor will attempt to export or send the data using a variety of methods, such as simply sending an email, changing the web address where payments are sent, using a USB drive, or other methods. And so what we're really talking about today is, how, given the fact that an attack features these different aspects, and I'll actually go back to the slide, it features, finding a way into the system, then accessing the system and certain types of data, and then removing data, it's clear that we want to be able to somehow understand the relationship between these different activities. Human behavior as we see in the slide, leaves a trace. Multiple actions were taken by the bad actor at Tesla to remove the data. And so hence in these scenarios, any of these event logs collectively form the attack fingerprint. And so our question today really is how to understand and detect these relationships. So how does this all relate to data science? Well, the big question here is not only how can security teams detect and alert on specific events, but how can you actually understand, monitor, and alert and detect patterns of malicious activity that may be happening across multiple systems or multiple endpoints or multiple processes. And so that's where data science comes into play. So here's a little cartoon here. The man is standing at the side of the pool, and he sees the shark, but the swimmer clearly is in his own lane, and he's asking, what's he yammering about now? While funny, this actually makes serves as a great lens to the problem, which is sometimes when you look too closely at certain types of data or certain events, you fail to see the big picture. And so data science is also about looking at that big picture. So we're going to actually jump into, some of the common problems that are currently occurring, in many security teams and in many retail operations when it comes to managing a SIEM program, SIEM, which stands for Security Information and Event Management. So before we look at the bullet points, I want you to take a look at the actual graphic here so we can all understand, how a SIEM typically works. So in the green, you see the different devices that might be in a store. You have your security devices, such as firewall, also your security software, like antivirus. You have your network devices, like a router, a switch, a VPN. Excuse me. You have servers, you have applications, and then of course you have your various machines, your point of sale system, your back office system, site controller, and so on. And so the first step is being able to send logs from these discrete processes and systems, and then to be able to receive them centrally. And so that's what that column in blue is trying to indicate. And so once you receive it in that central engine, looking into the orange column, you want to be able to do interesting and meaningful things with those logs. Obviously you want to be able to detect potential malicious behavior and, security events. But if you look at the different areas in that orange square, you have the ability to do more than simply collect logs and then alert on discrete events coming from different endpoints. You can use algorithms to correlate these events, which is what we'll be talking about today. You can do some interesting reporting potentially. By visualizing the data, you can tweak or fine tune your alerting so that way you're only detecting what matters. And so these are just some of the things that are possible in a SIEM. Now, what's happening today, looking at these bullet points here, is that a lot of SIEM programs aren't actually using its full capability to detect relationships between different machines and different activities, happening in time. They're not able to detect relationships between different processes. And also, going back to the swimmer who couldn't see the shark, events are not understood in historical context. Maybe you are able to detect something that happened in a point in time, but you're not actually seeing that event, in context of what might have happened in the last 30 minutes, the last 60 minutes, but even the last 30 days and more. Certain types of attacks may actually be happening over the course of 150 days as a bad actor has access to your systems and is slowly removing data. And so that's why we need to be able to understand historical context. And so SIEM tools, like I said, have the ability to do more than what people are typically leveraging in them today. Obviously you can relate events. You can use statistical methods for regression to understand how events are corresponding to one another and whether any insights can be found in that data. You can also cluster events, meaning separate them intelligently into different groups. And ultimately, the last point is really one of the most important. By leveraging data science methods, you have the ability to actually make your security and information and event management program smarter over time. And so the more data that it receives, the smarter the program gets. So this particular table will give you a better idea as to what we mean by looking at the relationships between events rather than looking at things discretely. So when you receive data, events are not necessarily relatable by time, but what we're trying to understand is how can we relate different events happening in different areas on a network or across stores or across the entire chain by time. And so, I'll just go column by column so you can understand what's happening here. In the first column, you have, it's 1 o'clock, 1:01, 1:02, 1:03. You can see in the firewall column, you have different events happening in that firewall, over those minutes. You have event A, event B, event C, event D. Excuse me. Likewise, in your point of sale system, you have different events happening. Sometimes the same event is occurring again and again. Sometimes it's a different set of events. So that's why we have POS event A, then B, and then A again. Likewise for your back office, and likewise for every other machine and process that we talked about. And so what happens is that in different time periods, you could have a different combination of events taking place at the same time. And so because there are so many different relationships that exist between these different combinations, we want to be able to see that collectively in one place organized by time. And that's the only way we can truly understand these relationships and make some intelligent insights. So, another joke here, but, frankly speaking, this is very accurate to what's happening today. SIEM platforms are just being used as a log dump. You collect all the logs and hopefully you alert on some of them, and then it all kind of sits there. And like this wood in this pile, the logs aren't being put to any great use. They're just sitting there, and according to PCI compliance, hopefully you're able to access the logs from the last 365 days, so that way you can hand it over to an auditor if he's looking for any particular evidence. But that's basically the extent of where most security programs sit right now within retail operations, but also out, even some managed security providers and in other fields, other industries as well. Now, here's another problem that we're going to try to address today in our discussion on data science methods: false positives. So, many of you on this call here today are convenience retailers. Maybe you have just one store, maybe you're a single store operator, maybe you have 10 stores, maybe you have 50 stores, or maybe you have 600 stores. And so the ultimate result of that is that a retail chain can produce thousands of alerts per year in a SIEM platform, thousands, depending on the number of stores. And what happens is that standard processes that are happening, application updates, I'm going to turn it over to Thomas in a second so he can give you some more detail, but these standard processes can inadvertently trigger alerts. And so what happens is the security teams do not always have a way of prioritizing the alerts that were inadvertently triggered. And they don't always have a way of making sure that in any given period in time that they're addressing the most important alert. A lot of times it's the first alert in is the first alert they're going to address. And so to take a look at this graphic here, on the left you have a false negative, and so obviously there's the problem of not detecting alerts that you should be detecting that are related to malicious activity. But on the right, a lot of times we are detecting alerts that really do not, or receiving alerts that really do not need to be received. They're not related to any malicious activity. And so what happens is that your security team ends up spending more time on activities and looking through alerts that really do not matter. And that actually has a huge impact on the risk of an organization. So take a look at this attack timeline. An advanced attacker will first spend some time preparing and researching and seeing, how he can infiltrate your organization. And once he gets in, within 24 to 48 hours, he can start, really doing some things that could negatively impact your systems. And then if he's able to stay in, maybe he'll be there, or they, meaning the organization, will be there for 150 plus days as they go from system to system, such as the Sony hack, taking as much data as they can. Now, the point I want to make here, though, is look at that 24 to 48 hour window. We want to be able to detect and respond to the most important alerts as quickly as possible, or else it might be too late. Thomas, you're in this world all the time as a security strategist. what could be possible if an attacker is in your systems just for 48 hours? What is he capable of doing?
I mean, if it's a targeted attack, the hacker knows what he's going for. He knows what he's looking for. He's able to, cause as much noise as he wants, generate all these alerts that you're not going to be able to respond to right away. So then he's grabbing his data, he's modifying files, and then he's getting out of there. And, you can detect that, a week later when you're reviewing your FIM alerts. But if you don't catch him in that moment, it doesn't matter. He's got his information and he's out.
Got it. So, I mean, the bigger point is once he's made it into your systems and once there's a breach, it doesn't matter that he could have been there for 150 more days. Once there's an incident, then you already have a problem on your hands. And this graphic is actually from Microsoft, just to give you some context. So there's that 24 to 48 hour window, which is all that's needed to exfiltrate potentially data. So we have an understanding of the problem now that currently exists in security information and event management programs and in security operations programs as a whole. We have a sense that there's too many false positives. We have a sense that we're not always prioritizing the alerts that matter. We're just collecting logs without really doing a whole lot with them. And like we saw with the Tesla example, we don't really have people aren't really taking advantage of the ability to detect relationships between alerts coming from different systems or different processes. So now we're actually going to jump into our discussion on data science, and hopefully we'll be able to better understand how to have greater intelligence and accuracy in our security operations by leveraging data science methods. So the first point I want to make, there's a lot of buzzwords, right? Data science, analytics, machine learning. Any more you can think of, Thomas, that falls in that category?
Artificial intelligence.
Yeah, AI, exactly. And people use these words to make things sound advanced, but a lot of times it's important that a word like data science has very real meaning. So it's a methodology. It's not simply just a set of tools. It's not simply statistics. It's a full methodology. And I'm going to walk you through that right here. So the first thing is you need to identify what data needs to be collected and what you want to predict. I know at Omega, because we are PCI certified and we have to work with convenience retailers and be in the C-store space, we have a very specific guidelines on logs that we need to collect, as does any retailer that needs to be PCI compliant. Actually, I think PCI has a great document called Effective Daily Log Monitoring that pretty much gives the PCI requirements for what logs need to be collected. But I know that that's just what is happening in the car data environment. What more could we be collecting, Thomas?
I mean, there's sensors all over the store. There's many different machines that are not just in the CDE. You could have your TV monitors, any other streaming devices, computers maybe just for audio playback in the store. And being able to have all of those logs together and look at the events may, lead you to greater insights on who's in your store and what, attackers or bad actors are messing around with your store systems.
And so, if you look into that document, you can see, specific guidelines on, from a PCI perspective, what you need to be collecting. And so, fine, you identify what data needs to be collected, but you also have to understand what you actually want to predict. Now, quite obviously, we're trying to predict, from a security standpoint, malicious behavior. But what we also tend to forget, going back to that false positive example, is we're also trying to classify and predict what is not malicious behavior, so that way we're not wasting time on what doesn't matter. Now, as we looked at in the SIEM graphic, we need to have a way of sending those logs from those different machines and processes and programs and applications. And we also have to have a way of receiving those logs as well and centrally collecting them. As we looked at in that data table for different events happening in time from different endpoints, like firewalls and POS systems and so on, we need to make sure that when the data is collected, it's standardized in a way that it can all be in a format that is usable, and that it's cleaned in a way that you can immediately begin applying that data and getting insights from it. And you're not dealing with missing information or information from different times, and so you don't really understand how you can actually relate events. You want to have things in a time series format. And the next step, and we're going to be jumping into this with some demonstrations, is actually exploring the data. Before you start taking the data and crunching the numbers, and we're talking about, in this case with data, we're talking more or less about log data and events. There are ways to explore it. You can really, in the data science approach, the first thing you really want to do is visualize that data. Sometimes when data is in a visual format, you can see things that are very obvious that you would not normally be able to see if everything was collected in a table or a database. Such as two events that are occurring at the same time. You can see that visually in a graphic that events somehow have some kind of relationship to one another potentially. And we'll be going into that more. And so what we're going to do, over the next several slides is hopefully, walk you through the early parts of this data science method all the way through the beginning stages of developing a machine learning algorithm. And so with that, I'm going to throw it over to Thomas, and he has some demos that he prepared for you guys specifically that relate to exploring data. So let's explore.
All right, thanks, Ash. So, to start this off, we're going to get into the tools I use to be able to, visualize this data and start to create these connections between different events. The tool set I use is an open source set of software called the ELK Stack, which is Elasticsearch, Logstash, and Kibana. But the main important thing is we need to gather these logs from these endpoints. We need to ship them to a centralized server. So the Beats agent that I use is going to be our data collection or ingestion tool. It's going to be monitoring CPU, percentages, bandwidth percentages, Windows event logs, static text files, changing text files. All of that is then used, sent to Logstash and converted and indexed with Elasticsearch. And then Kibana is our tool that is going to be able to visualize this and create our patterns.
So I'm curious, why did you choose Elastic and the ELK Stack for this particular set of demos?
Mainly because it was free. So this is kind of, my setup for this demonstration. I had some, automated scripts running on a set of virtual machines, physical machines, that were then using that Logstash platform to send them to the Elastic Cloud where everything was hosted. I had some trial and error in setting this up. I first tried to do it locally just by downloading all of the applications and putting it on a Linux server. I ended up crashing my environment many times because I didn't have enough, RAM to distribute for these virtual machines. I was browsing on their website and I noticed that I didn't have to have a credit card. I had a 14-day free trial that I started about a week ago. And, that was, set up my example. One thing to, keep in mind when I'm showing these demonstrations is, I'm not teaching you how to set up these algorithms. I'm going to show you that, the data out there, there's correlations between the events that are happening on these machines. So you need to start exploring, what relationships your, endpoints and processes have with each other. So, the first set of, logs and events we're going to look at is going to be a simulated brute force password attack. The main objective was to gain access to a computer with a known user account. And, this is going to happen on multiple machines in an environment at once in a more systematic approach. As a hacker, we want to research the environment we're getting into, and we want to try and not get caught. So we know common thresholds for what typically sets off an alert in a SIEM platform, and we're going to try and stay below that and hide beneath the covers. So let's take a look at a video I put together of just finding a username for a Gilbarco environment. So Google is a hacker's best friend. You can find almost anything on it. So we're going to go to the petroleum equipment forums. Open up the search bar and just type in, passport username and password and just see what's out there. So when you enter, you get a hit, get some highlighted text. Let's click on the first link. Halfway down, we see two different users. We got a passport tech user and a call center user. We also see that they have administrative command prompts. So, we've got elevated credentials with that account. So keep that in mind, this information is out there for people to have. So you need other ways to, protect these systems. So we're going to then, compare that to PCI compliance and look at some of the standard thresholds that PCI mandates. So we're going to lock accounts out after 6 failed login attempts, and we're going to disable them for 30 minutes. Windows by default doesn't have any settings for, password age, account lockout duration, and thresholds. So we're just going to assume PCI compliance when we put together our automated script to, generate this data. So now that we have that context, we're going to jump into the Kibana platform and take a look at some logs and some events. So this is a failed login table. We've got the amount of failed logins for our y-axis, and our x-axis is going to be time. So we're able to see these logins over time. This is going to be for 2 different machines, Lab04 and Thomas DPC. At first glance, we see these failed logins. We don't really know what's going on, but we see some activity, and we want to find out more on, why are these failed logins happening? Are they malicious or not? So we're going to add some more data. This is going to be successful logins. So now, we have our same format with the amount on the left and the x-axis being time. We start to see a correlation. For every set of failed logins, there's a successful login, and they match up almost exactly. So now let's look at the automated approach. Here I've got a script that generates 4 failed logins every 31 minutes on 3 different machines. So taking those 2 graphs, we start to see that if an attacker is trying to compromise a system in an automated fashion, he's going to be able, you can see those correlations. They just look completely different than normal behavior. So we're going to pull that data out and, start to analyze it. Here we, saw that there was a correlation between a failed login and a successful login when it was actual user behavior. So, you start to think and make these connections. It's 12 o'clock, someone comes back from lunch. They're a little tired, maybe they start mistyping their password, but eventually they correct themselves. So being able to understand, what is human behavior? You have failed logins with an accompanied successful login.
So one thing that's worth clarifying is when we're saying correlation, we're not necessarily saying that from a regression standpoint. It's simply that there is some kind of observable relationship here that we think we can use to begin building some kind of algorithm to better detect suspicious login activity.
Correct. So now we're going to look at the login pattern from the automated script. We've got our 3 different set of machines. I know we just see yellow, but the other colors are beneath those lines. And we see our threshold amount. So, we know that 6 failed logins is going to lock out the account. 5 failed logins you can assume would generate an alert for the security team. So our hacker was smart enough to be able to use that public information and, start to create a script that would, hide behind, those scenes. And then we also see the time sequence. So, a cumulative failed login attempts are going to add up. If you space that out every 31 minutes, every 30 minutes is when that drops back down to 0. So we don't have these stacked failed login attempts. We can see his thought process in this pattern. And then we also, next slide. Actually, go back. Sorry, I thought there was one more. So, we can see the correlation. We can see the correlation between the failed login attempts, in our first example where they had the accompanied successful login, attempt with these failed login attempts without successful login attempts. So you start to generate these patterns in your head when you can visualize these data sets next to each other on what is typical user behavior and what could potentially be an automated malicious behavior. So let's look at some before and after. Before, when we're just using, a not smart SIEM or just, log collection and alerting, we've got common thresholds. Hackers know about these. We have isolated alerts. This machine had 5 failed logins. This machine had 5 failed logins, and we don't get to visualize those next to each other. Afterwards, we've got some behavioral insight. We start to understand how our employees are acting on a day-to-day basis. We've got these aggregated alerts where we've got multiple machines are having these multiple failed logins. And we also get visualization to, compare these and maybe predict some other activity in the future.
So Thomas, is it fair to say that simply by seeing that login activity in a visual form, we could pretty quickly detect that it was automated activity rather than user activity because of the time intervals? Is that correct, pretty much?
Correct. As we saw with the user, the actual user behavior, it was all over the place. It was 1 minute intervals, 4 minutes, 5 minutes. You know, in this systematic process, it's every 31 minutes with a specific amount of data. So this next set of examples, we're going to look at, you know, what happens once they get in, start to correlate that with other, you know, system events that are happening on that machine. So here we see our automated script is still running, but then we begin to notice that Thomas DPC, you know, strays from that 4 failed login attempts down to 1. And that one, you know, failed login attempt is successful on the other end. So you get to see, you know, where we're not having these successful logins, we get 1, and then our automated script stops. So if we take a look at what else is happening at that time, here I've got, you know, a file integrity monitor. We have our changed files on the y-axis and our x-axis is time. We see a basic pattern of maybe, you know, 2 to 8, changed files. And then at that same time, we see, you know, 47 changed files. So if we put that next to, you know, say in the top left, our network traffic with megabits per second, you know, megabits being on the y and time being on the x-axis, and we compare that to the same pattern of failed logins and successful logins, we're able to see at the time that he successfully got into the machine, we've got a spike in our network traffic and a spike in changed files about an hour later. So let's take a, you know, a closer look at these patterns. We see here, you know, this is an indication that the machine was successfully compromised. We've got, you know, a stray from our approach of the, you know, of our pattern with the forward failed logins every 31 minutes. And then we also see that behavior of a successful login accompanied to that failed login at the same time that the automated script was run, meaning that that machine was compromised. You know, not all FIM is created equal. File changes vary, you know, what changes these files. You're not going to have just one approach to collecting and alerting on these file changes and being able to weed out some of the false positives.
Just to add some context, if we refer back to the Tesla example, the specific bad actor, the insider threat, he changed operating system code. And so, you know, kind of some of these examples that Thomas is looking at could potentially alert on that kind of behavior.
Correct. So if we look at, you know, file integrity monitoring as just, you know, a standalone set of monitoring activities and disregard all context coming from the outside, we can start to see, you know, maybe there's an anomaly with 47 changed files when typically we only see 5. But if we accompany that with, you know, a spike in network traffic, a successful, you know, login attack where they're, you know, guessing our password, we can start to visualize, you know, what type of file changes are occurring and why these could potentially be malicious rather than, you know, just some sort of application modifying these files. So some other things to consider when looking at file integrity monitoring and when you're visualizing your data is, you know, if a folder, say files change in a folder path for that application, but there was no, you know, beginning process, nothing started that application from running. Versus on the bottom when, you know, you start up, say, you know, your Notepad++, and you can just visualize, you know, you start it up and it prompts you, hey, we've got to run an update on this application. You click yes, and then some files change. So, you know, if you've got these processes that are starting applications and, you know, the same application is changing the files, you can detect that rather than, you know, if I'm a malicious or a bad actor, I'm going to not start, you know, the application I'm about to change the files. I'm just going to change the files. So we start to see the behavioral activity between the two. You know, without the proper correlation of these other data sets, you know, we've got very noisy alerts. So before we've got no context to why these files are changing or what other system processes are happening around the same time. We've got frequent alerts, maybe 47, you know, alerts because these files changed. You know, and it's a first come, first serve alerting basis. This file changed, I'm going to look it out. This file changed, I'm going to check it out. And you don't get to, you know, get the aggregated account. So, you know, afterwards we can better understand these changes. We can prioritize which, you know, alerts we're taking care of, and we've then all in all, you know, reduced our false positives. So one thing to bring up is, you know, PCI mandates we have to review file changes every week. You know, if we go back to that 24 to 48 hour example of when the attack is, that's not going to be, you know, sufficient. We don't have to go back. You can visualize it. You know, that's not going to be sufficient for actually detecting these malicious file changes. We need to be, you know, reviewing this data as it comes in, having these insights to what else is happening.
Great, thanks, Thomas. So what we just did is only explore the data. We haven't yet fully started applying statistical techniques and creating algorithms, but already you can see that simply visualizing the data brings greater intelligence and accuracy into our security information and event management. And so the next question is, how can we use these tools to start easing the burden of security management? If we return to our data science process here, the methodology, the next step once we visualize the data and explore the data is we start thinking about how we can develop a machine learning algorithm. And here you can see that we have to first train the data in some kind of way, or train the algorithm before that model can start learning from new security events and logs that are being received by the SIEM platform. So we're actually going to apply just at a very high level so we can start understanding how exactly data science makes alerting more efficient. We're going to start applying some of the insights that Thomas gained from his exploration. So we'll call X multiple login attempts over regular intervals like we saw with that automated behavior. Let's just say 2 or more machines at a time that are receiving these regular attempts. With a sudden stoppage in login attempts after one of those machines has a successful login, we're going to call that a single variable when that happens. And we're going to define a separate variable when there is a specific pattern of file change activity, such as what you saw when an executable was not being launched even though files were changing. That could be a specific pattern of suspicious file change activity. So obviously, if X and Y are happening, that pair should be assigned a higher probability and probably fall higher in the queue as a higher priority alert. This ensures that if you're on a security team, or if you have a security team, that the more likely signs of malicious behavior are being addressed first, or else that 48-hour window could have already passed. Looking at the second bullet point here, whereas the specific pattern of file change activity may represent only a 5% chance of being a sign of malicious behavior, if you look at it by itself, when you look at the conditions of X and Y being met, it could represent a 33% chance of malicious activity. So by taking this approach, I hope you can get the sense that we start thinking in terms of probabilities. We start assigning priority in terms of the alerts that are coming into the system. So now here's the other side of that, where we actually start saving time and becoming more efficient. When the alert is examined, because we've already done the correlation ahead of time, the information collected in the SIEM has already established a potential relationship between X and Y. Hence, we've already pre-investigated before the alert came in rather than afterwards. We already have a sense of what different activities the bad actor could have taken on prior to producing that alert. And so basically the fingerprint, going back to that, is readily available to see. We don't have to search for it, which is what usually happens when a forensic investigator comes in and starts trying to understand the traces of the bad actor. We actually get that right up front. Now, one thing I mentioned is that we want to be able to create a SIEM program that learns, that improves over time. We don't want it to just stay static and perform in month 8 the way it performed in month 1. The more and more log data we receive, the smarter and smarter the program should become. So with data science, penetration testing actually has the ability to be even more valuable to your security operations because it can actually feed real data that represents malicious behavior. And so one thing that is typical is that security teams will receive an alert. That alert creates a ticket, some kind of open item that they have to look into. And then once they solve it and address it, and they find out that either it was truly the sign of suspicious activity, or if it was actually just a false positive, what typically happens next is they just close the ticket. It's all been solved, and maybe they use that as evidence for the auditor later on, but that's pretty much the end of that process. What we're suggesting here is that a SIEM program that leverages data science does not simply close tickets. Every alert is assigned a true or false value, which helps to train and refine models produced by the algorithm. So each time a false positive comes in, it's flagged as false, potentially, if you take that approach. And each time an identified threat comes in, the alert can be flagged as true. And so that's how security teams can help their SIEM platform learn. Something I'll quickly touch on is, analytics tools give security teams access to expert communities. You're not necessarily creating these algorithms and doing a lot of this activity in isolation. Hackers share knowledge and collaborate. That's actually one of those things that makes them so successful, whether it's state organized activity or if it's, mafia led or whatever it might be. There's a lot of information sharing that hackers do, whereas security teams too often operate in isolation. They don't share their findings with other security teams. There's not that same level of peer-to-peer knowledge sharing. What's cool about a lot of these analytics tools is that communities form. Thomas, you spend your days in this, either in Elasticsearch or using other tools. What do you see when you engage in some of these communities?
I mean, a lot of people, they'll just give you, some insights on what they recently found. So maybe, let's monitor these set of Windows events, but filter these things out. And those also correlate with, a spike in CPU usage, a spike in network traffic. And then they have these templates that you can apply to these systems. You don't have to sit there and create the algorithms yourself. They're readily accessible for you, as a part of that community.
Got it.
And that can even, if you're a smaller operator, having access to all of that data can kind of ease you into this process and start to get you started on, leveraging data science for security events.
So hopefully from seeing Thomas's exploration of the data and from seeing a very high level kind of explanation of how algorithms begin to be formed by using those insights, you have a sense of how the burden of security management can be eased due to the reduction of false positives, due to better prioritization of alerting, and due to having a fingerprint readily available when you actually look to investigate an alert. So we're actually going to move on. I want to try to speed up a little bit over these next couple slides so that we have time for questions. But we want to also understand how this data science approach to security can fit into an overall analytics strategy. So I'm going to just talk through this quickly. We often see at stores that many retailers are leveraging door counters. What they do is they measure traffic in a store, and they actually are smart enough to account for inbound traffic versus outbound traffic. So that way you have a true count of what the traffic in the store is at any given point in time.
Foot traffic, that is, not network traffic.
Okay, thanks. And so what you typically, what I'm showing here is, just basically some transaction data. You have a transaction ID, a transaction amount, and then you have time. And what a lot of retailers, and perhaps many of you on this call, use these door counters for is to get a sense of conversion rate. How many people that came into the store actually ended up making a purchase? And, so there's some of that door counter data. You have a time period, and then you have the total traffic over that time period. Now, what's interesting, and we will tie this back into security, is that, firstly, you can bring that data together to get a sense of that conversion rate if you just look at transaction volume. But if I take that door counter data and bring it back with my security events that we looked at earlier in the presentation, we can actually see how many people were in the store at the time potentially that an alert went off. Potentially it's a USB drive that was not authorized with a malicious file at 3 a.m. Maybe at that time that this hypothetical alert went off, our data shows that only 6 people are in the store. Well, that actually allows the store manager, if you contact him, to act a little bit more intelligently. Maybe he can remember back to who we saw in the store at that time and so on. But let's keep going with this. You can actually compare the same security events to conversion rate in the store, and here's where this becomes extremely relevant from an operational and security standpoint. We can see that some kind of security event happened starting at 3 p.m. And let's just say that the network is out. There's no longer connectivity and you're not able to process payments. Well, all of a sudden, by combining that with the door traffic data or the foot traffic data, you can see that your conversion rates have suddenly dropped. You can actually have a real sense of business impact, related to operational issues. And all this can happen within your SIEM platform. and your analytics platform.
Right, and Ash, that goes back to, we don't just want to collect logs for PCI compliance. There's many other devices in the stores that we're able to gather these logs for and put into that SIEM platform. It doesn't help if we have, two separate platforms for these types of logs.
So bringing this all back together, I think, an obvious and good question is that, yes, this is very fun to learn about. This is, it's cool to see how we can make security more accurate and more responsive and more efficient. But is this really feasible? One thing, as everyone on this call knows, being in the C-store space, it's one of the most complex retail environments. There's so much going on. You're always putting out fires. Is it really feasible to be dealing with data on an active basis in order to improve the level of security at the store? So with that question, I would probably address it in a few different ways. And Thomas, feel free to jump in if you have any other thoughts here. The first thing is, if you have a security team and you haven't used a lot of the more advanced tools, get started by simply downloading and exploring the tools. I know, Thomas, it didn't take you very long to get going with Elastic.
Right. It was a 5-minute setup with the free trial when I finally decided to do that online. And it's very easy. And it doesn't take long to send that data. You punch in the URL you're sending it to in your passcode, and then you can just start visualizing and getting a sense of what you're looking for or what you want third parties to look for if you hire someone else to do this work for you.
Right. So it's just a matter of taking small steps forward. If you're a single store operator or you have, 10 stores or 30 stores, and you don't want to be addressing security to this level of depth, you can always, of course, partner with a managed security service. Now, one thing is, if you have an understanding of some of these approaches, you should always be able to test any potential security partner for their knowledge. And this brings us to our third point in terms of understanding. Even if you are not a technical person and you're more focused on the business side of things, you do need to understand how attacks could potentially occur. In the Tesla example, it was important for Elon Musk to understand how attacks might occur, what insiders might do, and how that could disrupt his operations. And so I would urge anyone to simply, further their understanding of attack patterns and try to understand how data science could improve your program, whether it's being done in-house or through a third party. And either with your own security team or a third party, always test them for their knowledge and make sure that they're thinking about incorporating these more advanced approaches.
And then to play off that, when we talk about communities and having access to that, Conexxus is the community. Reach out to some of the resources in this organization and see what they're doing for this and how they can help you out.
So that's basically all we have for this presentation. I hope we addressed these 4 areas as best as we could and that you furthered your understanding. Here's our information if you ever want to chat more about data science and security. But with that, Cara, I'm going to turn it over to you for hopefully a few minutes of Q&A.
Great. Gentlemen, thank you very much. Great information today. And so we do have a couple of questions. The first question is, and I would, again, encourage everybody to type in their question in the question panel of the GoToWebinar. The first question is, what are some of the commercial alternatives to ELK?
Some of the big ones off the bat, you can think of Splunk, Graylog. I think we had a slide where we had some other,
yes.
Examples here.
I think you did, yes.
Right. I mean, those are some of the tools off the bat that I can think of and that we, commonly see out in the field today.
Yeah, you'd mentioned that the one that you used, you had a free 14-day trial and it was pretty easy to set up. So that's
yes,
pretty great.
And I didn't even need a credit card, which is, good as a young kid.
But a knowledgeable one. So could you talk about some of the precautions that folks should take to safeguard the log databases and the indexes?
Sure.
Seems like that would be would be a gold mine to an attacker.
Sure.
So Thomas, I think for ELK Stack, you were using Amazon Web Services to host it, if that's correct.
Right. Also remember, you want to protect this data when it's in flight. Make sure that you're using, encryption standards that are up to par with, security these days. You're using trusted certificates. And then if you have, say you're a third-party manager providing, these services, or you're interrogating a third party that is hosting this data, you want to find out how they're indexing their data. If other customers that they have, are we on the same shared server? Are we indexed in the same logs as other customers? Just so we can create that separation between accounts and log data.
Great.
Great. And obviously it gets more complex than that, but
right. And I think that you had mentioned that for folks that may not want to do this on their own, or even if you are a big company, you still may want to outsource it just because you don't have the bandwidth or the people or even the systems. So as you mentioned, there's a lot of folks out there that are using the security appliances today, such as a firewall provider. But I think that some of those services may be some basic logging. So talk with them, because I think that most of them offer enhanced services as well. And certainly your company does as well, which is why this is near and dear to your heart. So, so please reach out and ask questions. And there are no further questions. So again, please everybody stay on and answer the survey questions in the email link that we send you. That will be there in about 30 to 60 minutes, and then there'll be a link to get the deck. So thanks again, gentlemen, for sharing your knowledge with us today, and thanks everybody for attending, and enjoy the rest of your day.
Hey, thanks for having us, Cara. We really appreciate it.
Thanks, Cara. I appreciate it.